Yo YouTube, Jay Kilroy here, back in the shop. It's October the 2nd, 2015. Weather is beautiful outside. It's a Friday. Crisp, nice. Can't ask for anything more. If the weather stays like this, won't be able to afford to live here. So I want to tell you, we're going to do some work on the drill press vise, and I want to give you an update on the drill press. Got the drill press working, got the electrics worked out. It wasn't the contacts as I originally had thought. I took Brian Block's suggestion. Check out his channel. I'll put a link down in the description. Maybe I'll pop a card up here on the screen. Check out Brian Block's channel. He does some fantastic work, very interesting work, big machines, big cuts, just kind of work I like. Anyway, he suggested that, he said, being the tightwad that he was, he would take the contacts out of the contactor and silver solder them, because normally when the contactor's buzzing like that, you know, they're dirty. Well, the contacts were heavily worn. They barely existed. They were very oxidized and coated. So I took them out, took the contactor apart, took the contacts out, polished them down with a little bit of emery, and then I silver soldered onto the contacts, a little blob there, right, onto each contact. And then I took a file and just filed a very small little flat on the surface of that new contact material. And then I put everything back together. No joy, still buzzed like a sun. So I said, well, maybe I had a viewer that suggested that maybe my control voltage was not up to par. I do not remember who that was off the top of the head. It might have been several people. You guys were right. So I'm checking the output of the control transformer, and I'm only getting about 70 volts across the output of the control transformer. And immediately I'm thinking, well, it's not 24 volts AC or DC, obviously. So next normal control voltage is 110, 120, right? AC. So I expected I was about half. Well, so I said, whoa, maybe the machine was originally wired up to 480. It is most Alzmetall machines, as I've been informed, are 380 volt machines. It's a European, I guess, voltage. This machine is actually a 240, 480 volt machine that came out of a factory here in the United States, Tecumseh Engine Factory, I believe. So the motor was wired up properly. I checked the motor wiring, and the motor was wired up properly for 240 volts, which is what I have here. I have 208, 120 three-phase here. And so I have no documentation on the transformer. No wiring diagram, no instructions, no nothing. Looked all over the internet, could find nothing. I found a manual for the machine on Scribd. Link down below if you ever if you need this manual. Full manual for the machine. So I learned a lot about the machine, which is great. But there was nothing in the manual about the wiring diagram or wiring it or hooking it up, nothing. So I was like, well, this is useful. So what I did was I said, well, you know, on the secondary side of the transformer, there's 4 output terminals, numbered 1, 2, 3, and 4. And the way it came configured, 1 was jumpered to 2, and 3 was jumpered to 4, and they were taking power off of 1 and 4. I took the wires, all the wires out of the secondary side, and I jumpered 2 to 3, center tap style, right? I jumpered 2 to 3, which is normal. Something's going to be jumpered. It's the only way you ground your transformer. So I jumpered 2 and 3, powered it back up, checked the voltages on 1 and 4, and voila, at 125 volts. Actually 127 volts. My voltage runs a little high here. So anyway, I've had it as high as 254 volts. Put it all back together and the baby runs quite nicely. I did a little playing around with it. The tap cycle works. Let's bring the camera over and I'll show you where we are. A couple of things that need to be fixed on the machine. It's going to be more than one project for sure. What we're going to work on today is the vise. I'm going to show you the table and the vise, which are factory items, and we're going to work on the vise. At least get a start on reconditioning this drill press vise. Hey YouTube, reshooting a segment that I did on the drill press, doing this after the fact because the original file was corrupted. So I got the electrics fixed, like I said. I've got the drill press powered up, and I'm just going to kind of go through it with you. So this is it's a Morse Taper 4 machine. It has what's called the a production table. So if you watch this, you pick this bar up, the table is articulated in the X and the Y. It's really handy, kind of heavy right at the moment. I've got my 8-inch Kurt sitting on it for the moment. I need to clean it all up. But let's go ahead and power her up. We are in a high range, which is 240 to 710. Said it's not a real high-speed machine, but it is rated to drill 50 millimeter in steel. It's a Reeves drive type setup. The tach doesn't work, we're going to have to fix that. Here's the power feed. We're in the fastest feed setting, which is 110 thou. Got 200 millimeters of pull travel. Knock down the low range here. Low range is 80 to 240, so a whole lot slower for turning a big bit there. Again, that feeds. What I want to show you now is the tap cycle. It's got a tap cycle set up. You see down here, there's two buttons, 2 feet buttons, a red button and a black button. The red button is off. The black button is reverse. So let's get it going. So you just have your part in here, feed your part down wherever your tap would grab, start pulling you down, and you get down where you want to, press and hold, it reverses, let off, back to forward. There's an automatic setup in here that uses a bar that came up here, which is missing. We'll have to make that. That'll be a project. This square tab here had this hokey shield on it, and this was welded onto the spindle, and it's not a factory part. So I don't know if we're going to use that or if we're going to take the spindle out and remove it and clean that up. The original piece was a collar that clamped around the spindle right here, kind of like some mills and other types of drills use. So it had a bar coming up through here that had a stop that would, when you're in your tapping cycle, would pull down and hit this button. So hit this button and that reverses you. It goes back up, and then when it comes all the way back up to the top, hits this bottom button, it forwards it back down. So you have kind of an automatic cycle. You can set your stop up. You can just sit here and get it in the hole, get your tap in the hole, pull it down, boom, 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 and just work with it. So it's a really handy feature. It's definitely something that I wanted to make sure worked on the machine. The coolant pump does not work. there's a project for you right there. Like I said, the coolant pump doesn't work, the tachometer doesn't work, and we're going to need to replace this, the stop rod for this tapping cycle feature. I think it could also, in drill mode, I think it also works like this works like a feed stop, this bar here. So this bar had a stop block, had a bolt that came out here, would come down and hit here, and would kick your feet out. So there's multiple reasons to get that working. So there you go. Let's get back to work on the vise. All right, got the vise on the table. I've kind of started looking at it, checking it out. It's interesting. There's an interesting feature in this vise. If you get to looking around, you see it's pretty worn. It's had some use. These two pieces of the bed here, these two plates, are actually steel plates that are bolted down to the casting. So they're held in by these little flathead screws. These look like about a 3 millimeter. I'm sure it's metric. Anyway, so I guess they expected you to drill into the bottom or whatever, and you know, the jaws here are pretty beat up. At least the fixed jaw is pretty beat up. The moving jaw is actually not in bad shape at all. The fixed jaw is pretty beat up. We're going to make a new fixed jaw for this thing, or maybe turn this one over, clean it up a little bit. The bed here is pretty darn beat up. I'll move the camera around here in just a second, and it's got quite a few little potholes. I mean, there's drill holes over here. How did you ever drill over here and back here? You know, nowhere near the workpiece. Or maybe they had a workpiece overhanging the top of the vise, whatever, who knows. Yeah, that was the cat kicking my ass. So anyway, it's an interesting piece. I'm gonna bring the camera around and get you a close-up on here so you can see how these pieces are bolted down. And then we will endeavor to get them out of here. I'm gonna have to remove the jaws because the jaws overlap. I'm gonna have to remove the whole sliding jaw assembly and the screw, which means I have to get up under the vise to do that. So we're gonna totally break this thing down to its component pieces and see what we're working with here. All right, looking at the vise here, straight down on it, you can see where I've pulled these screws up. There's two more here, two more here. There were two in the back on each end. So we need to get this fixed jaw plate out to get these last two screws out. Then we need to flip it over and get this moving jaw assembly and the screw out. So let's do that now. Like I said earlier, everything's metric. Oop. Bigger than that. I think it's metric. No. Maybe I was wrong. Just a sec. No, I was wrong. Everything's not metric. Maybe it's a 3/8 inch socket head. God, that's tight. Oh. Sorry. God. We might have to get her out before this is all over. Let me get something with more leverage. Got a little breaker bar. God. Yeah, this is nuts. There we go.
Well, that answers that question. It's not a left-handed bolt. Whew. Maybe it heard me talking about them. Oh, God. There we go. There we go. Sorry about the arm. All right, there's the two bolts. Here's the fixed jaw. You can see it's been swapped over already once. Well, no, that's a hole that's been drilled down through there. So there's the fixed jaw. It's in pretty rough shape. Both sides. I don't think we were using that. And then here are our screws that were completely full of gunk. Well, of course, all the rest of them I did came out pretty easy. As soon as I put it on camera, everything comes to a screeching halt. Isn't that typical? Let me just give that a little. Try to force some of the grunge out. Nope. I'm going to have to get a impact driver. Be right back with you. Alright, I got that played out. Used the trusty DeWalt impact with this nice extension that you get from McMaster Car. It has an O-ring tip that holds the bit so it doesn't drop out. It's made out of stainless steel and it's all one piece. And works real well. They have this length and then they have a 3-inch. I don't remember the part number, but it's made in the United States, and it's a fine piece of equipment. So anyway, all the screws are out. So and the fixed jaw's off. So now what we have to do is get the moving jaw out, and so let's do that. We have to take the screw out first. Get the screw disconnected here. Let me roll that in so you can see it. This is where the other screws, where the steel plates don't go all the way back. They go back to, right here. So there's a little bit of room behind there. Again, I was expecting metric. And well, getting some odd size. It's 4mm, so it is metric. This is obviously probably a Hodge. This isn't the factory fastener, I'm sure. So I'm not going to worry about maintaining it. We'll be redoing this, so ignore my technique of using pliers to hold the nut. I will not be reusing the nut. Nor will I be using that screw. Okay. back the screw out. It's a square cut thread, by the way. It's not a... I can square... Yeah, it looks like a square cut. I guess you could say square. Maybe it's a buttress. But the flanks of thread are... Alrighty. We got the baby apart after some... no blood, but some sweat and tears here, for sure. It was a combination of metric and standard fasteners. The screws, the bolts, these bolts that were holding the back fixed jaw on were standard size. These are 3/8 by 16, I believe, or maybe 7/16 bolts. The ones holding the moving jaw on were metric, and one of them is busted. And there's the screw in the moving jaw. So that probably relegates the moving jaw to the trash heap rather than try to get it out. Got the moving jaw carrier off here. Got the plates, like I was talking to you about, that covered the bed. Both of those off here. So what we're down to here is the bed, and in its raw form, not in too bad a shape. None of the holes, none of the marks penetrated these steel plates, and there's a couple little divots here in the center groove down in here, but no major divots. So what we're going to do now is we're going to clean this thing up. Probably just going to throw it in the back of the truck, take it over to the car wash and hit it with the high pressure and blow all this gunk off rather than do it here, and get it down clean to where something I can work with. And then we'll take a nice long look at it. For sure we're going to make 2 new vise jaws. We're going to make two new plates to cover this bed up, for sure. And we'll inspect the rest of it. Here's the retaining plate that retains the screws on the bottom. Look at the grunge packed in there from years of use, and that retains the moving jaw under the vise. It was really loose, so we're probably going to make a new plate, resized to hold this jaw down tighter and better fit. Got the screw out. Screw's in pretty decent shape. I mean, it has some wear, but it's steel. This is bronze, and this is the female screw. And while still functional, it is pretty heavily worn. But I don't know that in this case, I don't know that it's really worthwhile to replace it. It's certainly usable, and I don't know, that's something we'll consider here in a little bit. So that's where we are. So let's get this thing cleaned up and then come back to you. Hold on. Here's the fixed jaw and the moving jaw. You notice anything? Look at this side, and you will see where this lip that keeps the fixed jaw from twisting is gone, right? It's nothing but grunge, totally gone from this side of the fixed jaw. So we're going to have to consider what to do about that. As far as fixing that, I could mill this whole side down, make a steel plate, or maybe I could mill this bottom piece here down, make a steel plate to go back in there and replace this jaw. This side is probably what I'll do, and just screw it in to this cast iron piece and tighten that assembly up. But yeah, that's definitely more work that has to be done. So it's not in as good a shape as I thought it was. Hey YouTube, Jake Kilroy here, back from cleaning these parts. So I hosed them down with some Purple Power, let them soak for a little while. and then hit them with the pressure washer. That knocked off most of the grunge, but there's some really stubborn stuff. Been gummed up on here for God knows how long, and was difficult to get off of there. Right before we broke for cleaning, I showed you this failure right here. And I'll hold it up. So there's the missing piece right there. It's missing over here. You can see the broken section. The vise, that edge rides here along this edge and keeps the two edges combined keep the vise jaw parallel. The center boss here does not ride on anything here in the center. It's smaller than the center hole, and it doesn't bear on anything. So it doesn't. The only thing that's there for is to bolt this retainer plate to. So we're going to kind of start from the bottom up. First thing I want to show you is this. The keys, they have slots for keys in the vise here, and they don't look like they're straight, but this key slot here on this end is centered in this bolt hole. I don't actually use these right here, but this key slot here is off center, and this one's pretty much centered. It's not a standard size. Here's a 5/8 inch key. 5/8 inch key does not fit. I checked the table and the drill press, and the slots aren't 5/8 of an inch either. So, but either way, assuming that I go make some keys that are the right size, I don't have any holes. I don't have any drilled and tapped holes here to mount keys to utilize the slots on the table. So that's the first pass. First thing we're going to do. Well, second thing we're going to do. First thing we're going to do is we're going to clean up. These two surfaces here are parallel and of the same height, roughly, give or take a few thou, I guess. We're going to clean this top surface up just a hair. We're going to clean this top surface up just a hair so that we can turn the vise over, sit it like this, bolt it down onto the mill table, and then we can clean this bottom surface up completely. And I mean, it's in pretty good shape. It's got some big divots and nicks right here around where the bolts were holding it in. It's got some pretty big it's got some big dings over here. I've stoned it and filed it a little bit, but we're going to go ahead and get it positioned on the KT so we can clean this whole surface up at one time. And once that's done, then we have a good reference surface to work off of from there on out. And what I'm would like to do is these two slots, the slot that this bears in here, the slot on this side is 12 millimeters wide. The slot on this side is 9.5 millimeters wide. So that's pretty tacky. So I would like to get this slot here on this side cleaned up so that we can make the keys here on both sides of the movable jaw the same size. Let me grab that. Got a phone call. All right, we got the Vise bed now that it's all cleaned up and degrunged, and I stoned the bed real good here. High spots all up in here along the ridges. What we're going to do is go ahead right now. We're just going to clean up just very slightly, clean up the top here and the top here to give us a reference surface. And we're going to kind of have a dance of reference surfaces. We're going to do this side, then we're going to do the back side, then we're going to do this side. So we're going to clean everything up, get everything square, and you know, get rid of all the high spots and burrs that this thing's accumulated over the past, who knows, 30 years. We're running a, looks like a 2-inch, 6 flute, high-speed steel end mill. We're going to cut this dry, and we're running about 216 RPM. Bring it in here and touch off. Alright, that's touching off. Let's pull it back. Zero our dial here. We're going to cut, we're just going to start off and take 10 thou off all the surfaces here. Feeding about 7.5 inches a minute. Now we're not going to try to cut this down until it doesn't have any flaws in it. We're just going to clean it up. Pretty good, actually. Oh yeah, cast iron. Cleaned up pretty nicely. Got 2 nice working surfaces, so I'm gonna go ahead and vacuum this up and flip it over, secure it, and then we're gonna get ready to cut the bottom side. All right, we're up here in the mill. We are bolted down, and Got 3 studs coming through the middle here. By the way, here's a tip for you. Old socks, tube socks, great rags. So we're going to go ahead and skim this just as little as possible, just to get rid of all these high spots and banged up spots around the edges, and clean this up, give us a nice surface to work from. Okay, YouTube, we are cleaned up, my dear friends. I'm pretty sure it's going to take me longer to clean the cast iron off the mill than it did to make the cut. But you see there, we got a nice surface. Didn't quite clean up here and here, but pretty much everywhere else. And here's all the 2 passes we made to have something to rest on. I could have done this differently. Another way to do this cut would have been to put the bed up on parallels so that the cut was referenced off the bed. Now that the cut's been made, I can check the surface of the bed and see how parallel it is with the bottom. And if there's any issues with the bed, we can take a skim cut in here in the bed to clean it up parallel to the bottom. That's the. But if it's okay, I'm not going to mess with it. I've ordered stock to make these little babies, these little covers that go in here. I thought for a second that they might have been somebody's repair. The problem with that is that this distance right here, there's a big gap right here if you don't have these pieces in place. So, and you can tell this is as cast, so it's obvious that these were a design feature. I've ordered some stock to make those out of, just some 1/8 inch. These are 1/8 inch thick, and then we're going to make, also the next video we'll be making some jaws to replace these that have been beat up or have bolts broken off in them. And
we're going to go from there. We also are going to talk about repairing this piece right here. In order to get a better grip on that, I think I'm going to have to CAD it up first to find out what I really need to make to fix it. So what we're probably going to do is, as you can see, this tab's missing, right? I showed in a previous video. Probably going to mill a chunk off this end and then make a rectangular piece to set in here to take the place of this tab, and then silver solder it or braze it in place, and we'll leave it big, and then I can trim the bottom and trim the inside to get a good fit here on the vise, so that the jaw doesn't twist. Right now it can twist a lot with that missing piece, so we're going to replace that piece, and then after that we'll pretty much be done, and we'll see what we do with it from there. I'll be honest, I'm not a big fan of screw vices on drill presses. I prefer a fast acting type vise, but don't have one of those sitting around. So we're going to go forward with repair of this, and I'm sure we can find a use for it. Anyway, hope you've enjoyed this video. It's getting the drill press going, and I'll be back with number 2 in this series real soon. Be safe in the shop.